Hello students, welcome to new video. In this video, as part of revision series for basic electrical engineering subject for EC and mechanical tier Genco aspirants. So this is a video on practice questions of series and parallel connections and basics of electromagnetism. Let us start with the first question. If in a circuit voltage is reduced to half, so voltage is becoming V is equals to V by 2 and resistance is doubled, so resistance R is doubled to R, then the current will be, so what is the current I value is asking. What is the relation between current, voltage and resistance? I is equals to V by R. So I is equals to V is becoming V by 2 and R is becoming 2R. So this becomes V divided by 4R. So this I can write as V by R into 1 by 4. So current is becoming what? I by 4. So the answer is, correct answer is what? Quarter. So current is becoming 1 by 4. Next, second question. For resistances R1, R2, R3 and R4 are connected in series connection across a 220 volt supply. The resistances relation given: R1 greater than R2 greater than R3 greater than R4. So R1 is the largest value, R4 is a small value. The least power consumption will be in which resistor? So in which resistor the least power consumption is going to happen? So what is the power in the resistor formula? So P is equals to V square by R. It means what? So voltage across each resistor is the 220 volts is there. So P is equals to V square by R, and current through the each resistor is same. P is equals to, what is the formula? I square R. As the connection is series connection, current I is same. So power consumption is directly proportional to R. So which resistor is larger value, that resistor will have the large power consumption. Which resistor is smaller value, that resistor will have the small power consumption. So as the R4 is small, the power consumption is going to be small in the R4. See, R1 is large, so R1 is large means, so power in the R1, that is P1, will be large, and R4 is small, R4 is small, R4 value is small, so power consumption in the R4 P4 will be what? Small. So as the series connection is given, so as in series connection current is same, therefore I have taken P proportional to R. This is a formula, so this is not required. So answer is R4D. Next, third question. Three resistors 4 ohm, 6 ohm, 10 ohm are connected in parallel now. So now the connection is parallel connection. In which resistor the power spent is maximum? So connection given is parallel connection. In parallel connection, voltage is same. In parallel connection, voltage is same. So what is the formula? P is equals to V square by R. So as the voltage V is constant, directly I am writing P proportional to 1 by R. So what is the meaning of this? Less resistor will have more power consumption. Power consumption will be what? More. So here what is asked, in which resistor power is maximum? So less resistance will have the more power consumption. So less resistor means what? 4 ohm will have the more power consumption. So what is the answer? Answer is A. Next, fourth question. The coupling between two magnetically coupled coils is said to be ideal. Then coefficient of coupling K is. So coupling is ideal. Coupling is ideal means the flux linking with the first coil is entirely linking with the second coil. So coefficient of coupling K is equal to what? 1, or we say coefficient of coupling is 100%. So answer is, coefficient of coupling K value is, answer is what? K is equals to 1. Next, two coupled coils L1 equal to L2 equal to 0.6 and coefficient of coupling is given K is equal to 0.8. The turns ratio N1 by N2 will be. So whenever K value is equal to 1, we have a relation like N1 by N2 is equals to root of L1 by L2. We have a relation N1 by N2 is equals to root of L1 by L2. Here we are assuming K is equals to 1. So here K equal to 0.8 given, but we are assuming K less than 1 or K equal to 1. Then root of L1 by L2, that is 0.6 divided by 0.6. That value is equal to what? 1. So answer is D. Next, sixth question. 3 capacitors 2 microfarad, 4 microfarad, 8 microfarad are connected in parallel connection. Their equivalent capacitance. So when the capacitors are connected in parallel, total equivalent capacitance or total capacitance C equivalent is equal to C1 plus C2 plus C3. So it is 2 microfarad plus 4 microfarad plus 8 microfarad. So answer is 14 microfarad. Answer is C. When the capacitors are connected in parallel, the formula is C1 plus C2 plus C3. When the capacitors are connected in series, 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula. Next, seventh question. 4 capacitors. So how many capacitors are there? 4 capacitors, each of 20 microfarad are connected in parallel. Then total capacitance. So when the capacitors are connected in parallel, the two all the equal capacitor, the equivalent capacitance formula is N into C. N nothing but number of equal capacitors. How many capacitors are there? 4, and the capacitance value is 20 microfarad. So what is the answer? 80 microfarad. So answer is A. Next, eighth question. 10 capacitors. So total 10 capacitor, each of 10 microfarad are connected in series. Then combined capacitance is what? So when the capacitors are connected in series, then total equivalent capacitance formula C equivalent is equal to, and all the capacitors are of equal value, then formula is C divided by N. C is capacitance value. How much? 10 microfarad. 10 microfarad divided by how many capacitors are there? 10 capacitors. So answer is 1 microfarad. So C equivalent is equal to C by N for series connection, and C is equal to NC for parallel connection when the equal capacitors are connected. I mean equal capacitance capacitors are connected. Next, ninth question. A star arrangement of resistances, each resistance of 3 ohm, what connection? Star connection, and the equivalent delta arrangement will be what? So here star connection and delta connection, when we are working with the circuits, so in a circuit we may be required to convert star type of circuit into delta type of circuit, delta type of circuit into star type of circuit. See, let us say this is the star network. Let us say this is A and B and C. This is also called star network or T network. I am calling as RA, RC, and it is RP. Let us say I am not comfortable in the circuit whenever I am having the star connection, then I want to convert the star into delta. Then what I am doing, again these terminals I am keeping as it is only. This is A and this is B and this is C. See, between this A and B, this equivalent resistance of RA and RB, that is connected between A and B, that I am calling as RAB. And the equivalent resistance of between B and C, that I am calling as RBC. And between A and C, that I am calling as RAC. So now this star network is converted as a delta network. Then what is the formula of this RAB value? See, very simple. RAB is equal to, this RAB is a resultant of RA and RB. So RAB is equal to RA plus RB plus RA into RB divided by RC. So this is a formula. So similarly RAC is equal to RA plus RC plus RA into RC divided by RB. So in this manner we'll convert star network into delta network. Now how we will convert delta network into star network, let us see. Let us say this is RAB connected between A comma B. This is RAC connected between A comma C, and this is RBC connected between B comma C. So this delta network is there, or pi network is there. This we have to transform into star network. So again the terminals I am keeping like this only. This is A and it is B and it is C, and the resultant of these two resistors, resultant of this RAB and RAC, that should be connected to A terminal, that I am calling as RA. Resultant of RAB and RBC, that should be connected to B, and that I am calling as RB. Resultant of RAC and RBC, that should be connected to C, that is nothing but what, RC. Now delta network is there in the circuit, that I am transforming, changing into star network. Now I want to find RA value, I want to find, RC value I want to find, RB value I want to find. See, first of all I will find RA. So we have a derivation for that I am not discussing here. Directly I am using the formula. RA, this resistor is came due to this RAB and RAC. So in the RA we will get RAB, RAC. See, RA is equal to, what is the formula is RAB into RAC divided by RAB plus RBC plus RAC. So next I want the formula of RB. This RB is came because of RAB and RBC. So this RB is equal to this RB is resulted from these two resistors. So RAB into RBC by sum of all the three resistors. Simply I am calling as RAB. So in this manner we will transform star network into delta network and delta network into star network. Now one important question usually asked is, here let us see, this is a star network and this is R and this is R and this is R, and this I want to convert into delta network. So RA is equal to R, RB is also equal to R, RC is also equal to R. Three equal resistors connected in this star I want to convert into delta. So this is A and it is B and it is C, and it is RAC, RAB and RBC or RCB. So what is the RAC formula? Already we have discussed. RAC is equal to RA plus RC, RA plus RC plus RA into RC, that is R into R by R square by RB. RB is also nothing but what, R. So we get R plus R plus R, that is equal to, what is the value, 3R we got. So RAC is equal to, what is the value, 3R. Similarly RAB is equal to what, RA plus RB. RAB is equal to RA plus RB, that is R plus R plus RA into RB divided by RC. R into R square divided by R. So R square divided by R get cancelled. Again we will get what, 3R. So just clearly observe, R, whenever equal resistors are connected in star connection, when they are transformed into delta network, they are becoming 3R, 3R and 3R. So they becoming 3 times. Just remember that formula. R becomes 3R, 3R, 3R in the delta network. Next, let us see delta network. Delta network equal resistors value have taken. This is A, RAB, this is B, and this is RAC, this is C, this is RBC. But RAB is given as R, RAC is also given as R, RBC is also given as R. Equal resistors are connected in delta form. Then the star network value I want. A, this is RA, and it is C, it is RC, it is B, and it is RB. Now I want RA value. RA is equal to, what is the formula? RA is the resultant of RAB and RAC. So RAB into RAC by RAB plus RAC, that is equal to R into R by RAB plus RAC plus here RBC will come. R into R plus R plus R. So all the three values. So R square by 3R. R square by 3R is nothing but it becomes what? R by 3. So similarly, if you calculate RB also, you will get R by 3. If you calculate RC also, you will get R by 3. So what is the meaning of this? R, whenever equal resistors are connected in delta form, when it is transformed into star network, it becomes R by 3, R by 3, R by 3. So this is only when the equal resistors are connected. So from this again, whenever star network is there, and this is a delta network, equal resistor R comma R comma R, they are becoming 3R comma 3R comma 3R. Just remember. So this is about what? Star to delta. Next we will see delta to star. So in delta network, R. Now we will see star network. They become R by 3 comma R by 3 comma R by 3. So it is very important thing. And here, how to remember this formula without any confusion means, you take the star is a, here we have open but delta is closed. You take star as a weak network, delta as a strong network. So weak to strong network value is increasing, becoming 3 times. And this delta is a strong closed one. Strong to weak value is reducing, R by 3 value is reducing. So in this manner you remember the formula. But these all applicable whenever equal resistors are there, then only these things are applicable. Now let us see the ninth question. Ninth question here. A star arrangement of resistors, each resistance has 3 ohm. Star arrangement, each resistance 3 and 3, and equivalent delta arrangement. Just now we have seen weak to strong, that means 3 times. So 3 into 3, 3 into 3, 3 into 3, it becomes what value? 9 ohms. So answer is what? A. Next, ninth question. RA, RB, RC, R in star network, RAB, RBC, RC in the equivalent delta network. So star we have R, then asking delta network. So star to delta, weak to strong network, 3 times again, 3R, 3R. So answer is what? B. Next, 11th question. Three resistors each of R ohms are connected in delta. So each resistance value is R. Their equivalent star network value. So just now we have seen. So strong network to weak network by 3. R by 3. R by 3. R by 3. So answer is what? C. Next question. The value of resistance in delta connection is 3 ohms. So value of resistance, each resistance value is 3 ohms. In equivalent star connection is, so star connection becomes what? 3 by 3. So answer is what? 1 ohm. Next, let us start with some questions on basics of electromagnetism. The magnitude of the force acting on a current carrying conductor in a magnetic field is independent of, so force, whenever current carrying conductor is placed in a magnetic field, force is going to exert on the conductor. So that force is independent of, that means force does not depend upon what? So usually what is the force formula? F is equal to BIL sin theta. Depends on the flux density, depends upon the current, depends upon the length. Depends on flux density, depend upon the length of the conductor, uh, depend upon the current flowing through the conductor, but does not depend on the cross sectional area of the conductor. So independent of what? Cross sectional area. So force acting on the current carrying conductor does not depend upon the cross sectional area of the conductor. Answer is what? C. Next, second question. Fleming left hand rule is applicable to. Fleming left hand rule is applicable to DC motor. Let us see some previous questions on basics of electromagnetism. A car having an axle of 2 meter length. So length is equal to 2 meter and traveling at 72 kilometer per hour. So velocity is equal to 72 kilometer per hour. It is given kilometer per hour, but I'll convert into meter per second because it length is in the meter per second. So 722 into 5 by 18. So we will get what? 20 meters per second. And its vertical component of the earth's magnetic field is 40 micro Weber per meter square. Weber per meter square nothing but what? Flux density. So flux density B is equal to 40 micro means 10 to the power of minus 6 Weber per meter square. Everything I have converted into meters only. Then EMF generated in the axis of the car will be, so we want to calculate the EMF value. So what is the EMF formula? BLV sin theta. So as a vertical component is given, theta becomes what? 90, sin 90 becomes what? 1. So E is equals to BLV. So what is the B value? Flux density 40 into 10 to the power of minus 6, and length is 2 meters and velocity is 20. So here 20 and 20 becomes what? 2 into 20 becomes what? 40. 40 into 40, it becomes 1600 into 10 to the power of minus 6 volts, or we can say 1.6 millivolts. As the uh, options are given in millivolts, I have converted into millivolts. 1.6 millivolts. Answer is what? B. So remember this formula, E is equal to BLV sin theta. So make sure that you convert all the terms in the same units. Next, in a telephone receiver, the size of each two poles is, so 1.2 centimeters into 0.2 centimeters. That means area is given. So 1.2 centimeters into 0.2 centimeters. And the flux between each pole and the diaphragm is 3 into 10 to the power of minus 6 Weber. So flux is given, that is 3 into 10 to the power of minus 6 Weber. The force attracted to the poles will be, we want to calculate. Let us this convert into meters. 1.2 into 10 to the power of minus 2 and 0.2 into 10 to the power of minus 2, and this becomes 0.24 into 10 to the power of minus 4 meter square. And we want to calculate the force. So the force attracted to the poles, what is the force formula? B square A by 2 into mu naught. So B is flux density. Again, flux density we have to calculate flux by area. So what is the flux value? 3 into 10 to the power of minus 6 divided by area, 0.24 into 10 to the power of minus 4. So this flux density, if I convert this 10 power minus 4 into 10 power minus 6, then it becomes 24 into 10 power minus 6. So 3 by 24 means what? 1 by 8. Again 10 power minus 6, 10 power minus 6 get cancelled. Flux density is equal to 8. So if I substitute all the values in the force, so we will get the answer 0.149. So approximately 0.15 Newton. The formula is important. F is equal to B square A by 2 mu naught. Next question. Third question. In a n-turn coil, so how many turns are there in the coil? N number of turns. Flux through the each turn is, this is T cube minus 4T, and it is given in terms of what? Milliweber. The magnitude of the induced EMF in the coil at t is equal to 5 seconds is 7.1 volts. So magnitude of the induced EMF is equal to 7.1 volts at what time t is equal to 5 seconds. Then number of turns in the coil, so n we want to find out. So EMF induced in a coil, according to Faraday's second law, EMF induced in a coil is equal to minus n into d pi by dt. But as a magnitude is given, so if I take the magnitude, E is equal to, it becomes what? N into d pi by dt. So we want to find out the n value. E is given, flux is given. So E is equal to how much it is given? 7.1 is equal to n value we want to calculate, d by dt of flux, that is t cube minus 4t. So 7.1 is equal to n into d by dt of t cube, 3t square minus 4, and just you substitute t is equal to 5 seconds over here, then you will be calculate the n value. N value you will get around 1000. Just remember the formula, E is equal to n d pi by dt. 1000 is the answer. Thank you. We'll discuss about the DC generator in the next session.